Hello everyone, it is Nick from That Student Life Australia and welcome to the very first video tutorial for the new 2018, or commencing in 2018, HSC syllabus. We are going to be covering chemistry to start off with, and hopefully we'll eventually get around to some biology videos, but we're going to start off with preliminary chemistry, and the very first topic that is called properties of structure and matter. So let's look at the very first focus area, which they have titled very creatively, properties of matter. And the first dot point in that topic is to explore homogeneous or homogeneous, however you want to say that, let's say homogeneous mixtures and heterogeneous mixtures through practical investigations. And this dot point actually has a second part, but for the sake of not making this video very, very long, we'll explore the first half and then we'll do the second half. So this dot point says to do this using separation techniques based on physical properties. So what we want to do first of all is I want to actually just recap, what a mixture actually is, and we're gonna do this first of all by sort of looking at what elements, mixtures, and compounds all are, so making sure we can distinguish the difference between all those. So we'll start off with elements. We'll say elements. Okay, so first thing you need to know about me is I have cursive handwriting. I try to make it as neat as I can in these videos, but there's only so much I can do after 20 years of writing cursive, or not quite 20 years, good 13 years of writing cursively. Alright, so an element is defined, an element is defined as a substance that consists of only one type of atom, and what do we mean by one type of atom? What makes an atom different from another type of atom? So let's just change colours for a second. We'll illustrate this a little bit better. What should we use? Green. I like green. Okay, so an element is a substance that consists of only one type of atom. So, for example, we might have a substance, and we'll say this is an atom, and I'm going to draw the protons in here. Let's say it's got 5 protons. Okay. Now, if this substance is going to fit the definition of being an element, if I can look at that and say, hey, that's an element, all of the atoms that make up what I'm looking at have to have 5 protons. And, this could go on. I could keep drawing these. Just imagine they all have 5 protons in there, and I could say, hey, that's an element. As soon as, there's not, or there's a substance that doesn't contain 5 protons, or isn't made up of something that is exactly like what these atoms are here, we can't call it an element anymore. It's something else at that stage. So as soon as we start introducing different things into this assortment, then it becomes not an element. We'll go into the more specific details of what not elements are. So anyway, just to recap, an element is a substance that consists of only one type of atom. And what makes an atom unique is the amount of protons that it has. So for example, here we saw this is an element because it only consists of atoms made of 5 protons. Okay, what we'll do now, we want to define what a compound is. So we'll say a compound. So a compound, by definition, is 2 or more different atoms that are chemically bonded together. So we'll say 2 or more atoms. Now remember, we just said atoms are, or what defines an atom from being different to another atom is basically how many protons it has. So if, one atom that has 4 protons and one atom that has 17 protons, sort of is chemically bound or bonded to another atom, so to speak, we call that a compound. So 2 or more atoms chemically bonded together. Now, I know this particular part is not explicitly required from like the HSC syllabus, but as far as the concepts that are being discussed, this is basically prerequisite knowledge. So you should have learnt it maybe in year 10. If you don't remember it, it's always good to have like a quick recap. Even if you're sort of vaguely familiar with it, it's good just to have that bit of a recap and understand these very important definitions. Okay, so now that we know a compound is 2 or more atoms that are chemically bonded together. So for example, I might have a blue atom here that has some amount of protons in its center, and then I might have what I hope is, it's a grey atom, and they're sort of chemically bonded together, and if I have a substance that is only made of this type of material, so a blue atom bonded to a grey atom, and you imagine this unit just kind of repeats itself. That might be a slightly different colour, but this unit basically repeats itself in the same way this atom up here. Just this is a unit that repeats itself throughout the whole sort of substance. This is a compound, and we're not limited to 2 atoms. It could be 200 atoms bonded together, but if it's 2 or more atoms that are chemically bonded together, we're going to call it a compound from now on. Okay, let's go to mixture. I've just noticed that I probably haven't included the little free trial thing on my Paint program below, which is a little bit embarrassing, but I've just noticed that now. Let's go on to what color should we use? Let's use white. A mixture. What's a mixture? So a mixture, by definition, contains 2 or more substances, and they can be elements, they can be compounds, molecules, and that they're not chemically bonded together, and they can be in what we call a different phase from one another. So you might have part of your mixture, which is a gas, and another part, which is a liquid, and another part, which is a solid. Those are the 3 phases of matter, if you like. So, let's write our definition. So a mixture, we'll say contains 2 or more substances which are not chemically. And what do we mean by chemically bonded? I'm sure we'll come to this in more detail a little bit down the track. But essentially, when we have a chemical bond, these atoms are sharing some electrons. They are very close to one another, and they don't want to be separated. And whereas a mixture, when it's not chemically bonded, it's basically, you can pick it up with your hands and pull it apart. That's I guess the simple version at this stage, which are not chemically bonded together. Okay, so now we know what elements and we know what compounds are and we know what mixtures are. Now we need to address this big scary word up here, homogeneous and heterogeneous. What we'll do, let me just make myself some room up the top here. Where's my little toolbar? Here it is. Okay, so you guys can choose to write these down or not write these down. It's up to you. Obviously, your class notes might be a slightly better resource than what I am. or hopefully they are at least. This is just an additional online resource to help you guys learn that little bit more. We'll leave mixture down here for a little bit. Alright, so let's go back to writing. So we'll say homogeneous up here. So we'll define what a homogeneous mixture is. Homogeneous. So I keep interchanging the word homogeneous and homogeneous. I hear it said both ways almost every single day. So I sort of pick and choose what sounds better. Homogeneous mixture. Homogeneous mixture. Now, homo, this part here, means same. Okay, so if we can remember that, if you can remember one definition with these sort of two-part, or not two-part definitions that have an opposite meaning, I guess. If you can remember one definition, then by default, I guess you know what the second definition is. So a homogeneous mixture, if homo means same, is a mixture that looks the same all the way through. So if we say, is a mixture, and we'll use the proper definition, that has all parts. We'll say indistinguishable. Oh, bad H. Oh, indistinguishable from one another. Now, I don't know if I recap this at the start of the video, but I'm also a horrible speller as well as a bad handwriter, so you can feel free to rip into me in the comments section as far as my spelling is concerned, but my job here is to convey chemistry, not spelling skills, so I'm going to just hold up my end of the bargain as far as the chemistry is concerned. Okay, so a homogeneous mixture is a mixture that has all parts that are indistinguishable from one another, which means, for example, water, like your drinking water, as an example. You might have a nice cup of water, or a nice beaker of water in my case. Let's see. We'll really go the extra mile with my artistic skills, even blue. Basically, we look at this part of the water. It's different to. Doesn't look any different to this part of the water. All parts of the water look the same, even though on the inside of the water you might have some impurities, there's some fluorine in drinking water, and obviously you've got water molecules themselves. It's a big mixture. It fits that definition of mixture containing two or more substances not chemically bonded together, but you can't tell which part's which. And that's what makes it a homogeneous mixture, the fact that we can't point out one part that's different to another. So what we'll do now, we want to look at, what's a heterogeneous mixture? So a heterogeneous mixture, well, it's just the opposite. It's a mixture that has parts that are distinguishable. Oh, I missed a H in there anyway. Distinguishable. It's the same word as up here. Distinguishable from other parts. So from other parts. So there is a more formal definition, but just as far as conveying your understanding is concerned, it's basically homogeneous. I can't tell the difference. Homogeneous, yes, I can tell the difference. So your heterogeneous mixture might be two different looking solids or different colours, or you might have different phases. I think we talked about phases a little bit earlier. You might have a liquid with a solid floating in the middle. That's a heterogeneous mixture because they're two different parts. Okay, so now that we know the difference between all these things, now homogeneous and heterogeneous mixtures, we want to look a little bit about how to separate them based on physical properties, just like the dot point wants us to do. So we've got there in the end. It's only taken us, 10 minutes or so. I don't really have a timer running next to me. It's probably something I should start doing so I don't yabber on for too long. Okay, let's make ourselves a little bit of space. So there are some techniques, there are lots of techniques for separating both these types of mixtures. What we'll do is we'll look at sort of physical separation techniques. Now, I'm not going to go through all the physical separation techniques, but what I strongly recommend you do, you should be given, or at least when I was in school, I got given a nice sort of, not summary, but just a list of separation techniques for homogeneous mixtures and separation techniques for heterogeneous mixtures. And you should ask your teacher if he or she has a list of those types of techniques, or just simply Google them and just write a few down. I'm only going to go through a few. So let's look at if we want to separate what I'm going to abbreviate. I don't want to do any more writing. A homo mix. So we'll say homo mix separation. Separation anyway. So let's say, for example, we've got two types of liquids that we can't distinguish between. We know there's two types of liquids, let's say in a beaker. So two types of liquids in a beaker, but we can't tell the difference. Now, physical property is, or an example of a physical property is boiling point or melting point. So let's say we want to separate them based on the physical property of boiling point. Okay, so what I want to do is I'm going to apply some heat to this mixture, and what should happen is the one that has the lowest boiling point, that boils at the lowest temperature, will evaporate, and it will separate from the mixture which does not have a higher boiling point. So let's say one. We'll make a little list for ourselves. Is evaporation. Evaporation. Okay, so that's one separation technique that is based on physical properties. So what happens is we apply heat to a mixture of two liquids, and the one with the lowest boiling point is going to go away first. Now, there could be a bit of a problem if we actually want to separate them and retain both of those liquids. So, to introduce a slightly more complex separation technique for liquids, we'll say distillation. Now, essentially, you will learn distillation in far greater detail. Either now in class you'll do a practical, or you'll get a demonstration, or you'll learn it further down the line. I haven't learned the current syllabus, so I can't really speak to what's in it. But essentially, we can have a distillation setup which looks like this. I'm going to draw it in a different color. Basically, what you have is sort of some round-bottomed flask. It's got some liquid in it, and basically, there's some heat source, and just like in evaporation, we've got this big sort of condenser setup. This is quite a horrendous drawing. I hope no one in my chemistry faculty sees this, but essentially, to give you a rough idea, what happens is we have some line of water that runs in. And again, this is a very, very, very rough depiction of what distillation is. We have some water that runs in through the bottom here and out the top. And what this essentially does is it cools gases. So if we're evaporating the gas with a smaller boiling point, so it's going to go straight up here, and then we're going to cool it back down so it turns back into a liquid. And then what happens is we can collect it over here. Drips down, out like this. So, it evaporates, and then it sort of gets cooled back down, and then we can collect it. And that way we've got one liquid over here and another liquid over here. So that's one of the more common, I guess, separation techniques that you'll see, or at least that I've seen in my chemistry experience. Because this was such a horrendous, rough job, I think in the second part of this video we talk about the other dot point, which wants us to calculate percentage composition of elements or compounds. I might recap this distillation process, or link a really nice video that explains it in some crystal clear detail. So this is for some separation techniques for homogeneous mixtures. The most common kind of homogeneous mixture separation will usually be a liquid phase. However, we can have solid phase separations, and we can have gas phase separations also. But that's something I'll let you guys look up in your own time. In the second part of the second video that we'll upload, because I think I've really blown my time limit here, I'm going to talk about heterogeneous mixture separation, and also talk about calculating percentage composition. So I will see you guys in the next video. Sorry, this one went a little bit long. Bye.